Welcome to a new video. In this video we are going to talk about feature engineering techniques. Most of the times the raw data we collect is not ready to be pushed into a machine learning algorithm, and today we are going to learn dealing with this. I'm going to create a synthetic data for this tutorial. Let's start. We are going to start by importing Numpy and Pandas. And I'm not going to write the synthetic data creation codes on the video. I'm just going to explain to you after doing a copy paste. Now I'm going to create the numeric values of our data set and I'm going to talk about them. We have age, income and number of purchases, and number of samples is 1000, which means that we are going to create 1000 age values, 1000 income values and 1000 number of purchases. And age will contain the values between 18 and 65, like the minimum value is 18 and the maximum value is 65, and we are creating 1000 of that. And for the income we are using a random.uniform, which will create a data based on uniform distribution, and the minimum value here is 20,000 and the maximum value is $150,000, and we are going to get 1000 of this. For the number of purchases side, we are using random integer just like the age, and we are getting values between 0 and 50, and since we are using number of samples, same data, we are going to get 1000 of this. Okay, let's create category columns and let's talk about them. Like we have three categories, category A, category B and category C. We are using the number of samples again for getting 1000 of all of them. For the region side, we are selecting the category A, B, C selection here. You can see that random.choice, and for the subscription type, we are selecting between basic and premium. Here it is. I also wanted to show you this data creation thing and don't want to create this, so you can see how we create synthetic data using Numpy. Let's combine this into a data frame. For this, we are going to say data is going to be equal to the pd.dataframe. And we will open a dictionary. Here we will say numerical data, and what we are going to say is categorical data in the same format. Here it is. Now we are going to run this and let's see our data here. Great, just like we wanted. We have 5 columns, 2 categorical and 3 numeric ones. Great. Let's talk about our first feature engineering technique, handling missing data. Missing values are common in real-world datasets and can adversely affect our models. Let's see how we can deal with them. One common approach is mean imputation. This involves replacing missing values with the mean of the feature. Let's set one of the rows as none for each technique. Let's say data age and set this as none. And let's check the data.head for seeing it. You can see here that we don't have a value for this anymore. So what we are going to do is we are going to fill it with the mean. How we are going to do that is we will say data and age here, and we will use the fillNA method, and we will say data age dot mean here, mean. So one thing we are going to do with this is we are going to say in place equals to true, because this will update the data and we don't need to reassign the data again. So let's just check the data.head for seeing if that's changed or not. Here it is. You can see that it's changed. Also, let's just confirm this value by just take this here for seeing the mean, and we are going to check if both values are same. Yes, they are. Great. Another technique is median imputation, which is more robust to outliers. Let's set one entry as none again. Just use the same thing here, and we are going to see it's none again, and let's fill this with median. What we will do is we will say data, and we will take the age again, and we will say fillNA, and we will use data age, and we will use the median this time. And also we are going to set in place equals to true once again, and let's check if it's changed. Here it is. Let's confirm this also by just seeing the median of the age column and getting it. It's the same. Great. These were some of the missing data handling methods. So we can do other things like interpolation, etc. But these are the most common ones, but it changes with the case. Alright, let's discuss categorical feature encoding. Machine learning models require numerical input, so we need to convert categorical features into a suitable format. One-hot encoding is used for nominal categorical variables. Let's apply this to our region features. What we can do here is we can say encoded data is going to be equal to the pd.getDummies method. Here we are going to use, we will say data and columns is going to be equal to the region, and we will say drop first true. Let's see it. Here it is. You can see that we have true and false values for region category B and category C. So why we did drop first? I'm going to explain this right now. So basically, let's check this. It's false for region B and it's false for region C. So it's region A, and we don't need that information for knowing it's category A. So we are not using all of them. We just use that we need on one-hot encoding. Great. For ordinal categorical variables, we can use label encoding. Let's do it. We are going to take the help of sklearn here. We will say from sklearn.preprocessing import label encoder. And we will set label encoder with its class. And we will say data subscription type. And let's say for the new column encoded, and it's going to be equal to the label encoder that fit, and we will use transform method here. Data subscription type, and let's see. You can see that we have the numeric values instead of categorical ones here. For premium we have 1, and for the basic we have 0. Great, now let's explore feature scaling. Scaling ensures that features with different magnitudes don't bias our models. So this means that age takes values like between 20 and 40, but income takes 1000 values. So it's going to make significant change on our machine learning model. But if we scale them, it's not going to impact that much, and all the weights are going to be placed better. One common method is min-max scaling. We are going to say from sklearn.preprocessing import min-max scaler, and we will say scaler is going to be equal to the min-max scaler. And what we are going to do next is scaled features is going to be equal to the scaler.fit transform, and we will say encoded data, and we will take the age and income, and let's scale off them. We will take number of purchases. So next up we are going to say scaled data frame is going to be equal to the pd.data frame, and we will say scaled features, and columns are going to be equal to the age scaled and income scaled, and let's say number of purchases scaled. Let's see the scaled data frame. You can see that they are all scaled and they are at a similar value in this way. So we can use these features on our machine learning model for just giving them same chance on affecting the model. Like if the age is the most important factor here, because of the income it's not going to show much, but in here it's going to show its importance. Another scaling method is standard scaling, which we can also refer as standardization. If you have the stats class in your university, you probably heard about this standardization. Let's say from sklearn.preprocessing import standard scaler, and we will say scaler this time is going to be equal to the standard scaler class, and we will say standardized features is going to be equal to the scaler.fit transform encoded data, and we will take the numeric columns again age, income, and number of purchases. And what we do next is we are going to create the standardized data frame, which is going to be equal to the pd.data frame standardized features, and columns is going to be equal to the age standardized, income standardized, and last one, number of purchases standardized. And let's see this data frame. Here it is. Seems great. Now let's explore feature transformation, where we modify the distribution of our features to make them more suitable for our models. We'll start with the logarithm transformation, which can help handle skewed distributions. It's pretty much easier than scaling. We will just say data and we will say income logarithmic, and we will use Numpy's logarithm 1p method, and we will pass the data and income here, and let's see data.head for seeing what we created. So I just made a typo there on logarithm. Here it is, the correct version, and we are going to see it in here. Here it is. And another transformation is the square root transformation, which is really common. So let's also see that. We will say data, and we are going to say data and number of purchases square root, and let's just use numpy.square root here, and we will say data number of purchases, and see this. Here it is. We took the square roots of the number of purchases column. Great. Now let's explore creating interaction features. Interaction features are combinations of existing features that can capture complex relationships. Let's see how we can generate them. For instance, we can create an age times income interaction feature. So for this, we are going to say data age times income, and we will use data age, and we will multiply it with data income. And let's see that column here with data.head. It's going to be just in here. Here it is. You can see that. And let's create an interaction feature based on categorical data as well for the final technique. We will say data region and subscription, and we will say data region category B multiplied by data subscription type encoded. Here it is. Just use data.head here. We will say data region subscription, and it's going to be equal to the data region multiplied by data subscription type encoded. So let's just print it, and I'm going to explain it after showing it to you. Here it is. So as you can see that we multiplied this value with, I'm just going to show you here, with this value. So if the subscription type encoded is 0, then the region multiplied by subscription type is non-existing. So why this can be useful? If you just want to filter the members who didn't bought anything and in a basic subscription type, you can just filter it like this, and you can just take the others. So if you just take value counts from here, I'm just going to show you. Let's say data and region subscription dot value counts, and you are going to see the information about category A, B, and C here for the ones who purchase premium. So it can be beneficial if you don't want to analyze the basic plan users and etc. Great. That was all for this video. Thanks for watching. I'm creating content about data science. You can subscribe to my channel for more of it. Have a great day.